No one's going to watch the videos anyway. Okay, so let's go ahead and get started. Naming of the compounds. So you remember yesterday. Okay, you are now live on the internet. Billions of people can hear you. Okay, so what was I going to say? Viridiana Inguanzo ate 3 chalupas. That is now on the internet. You should see her. Oh my goodness. Okay, so yesterday we talked about naming, and we talked about how to name things based on certain rules. And the first was what functional group was present. The FG is just an abbreviation for functional group. So to remind you of some of the functional groups we had alkanes, we had alkenes, we had alkynes. All of these were, of course, carbon bonds. The alkane was a carbon-to-carbon single. The alkenes, carbon-to-carbon double. Alkynes, carbon-to-carbon triple. Okay. We had functional groups called alcohols. The alcohols had a carbon group, that's what the symbol R meant, attached to OH. The OH attachment to the rest of the molecule is what makes it an alcohol. Some other ones we had were aldehyde. I'll write the others over here. We had carboxylic acids. What else? We had the halides, I believe, and the ketones. I think I'm leaving off ketones. I think that's the only ones we went through yesterday. The aldehydes, remember, you had some carbon stuff. Attached at the end was this arrangement, which indicates an aldehyde. The C double bond O with the H here, that's an aldehyde group. A carboxylic acid, I'll write it above here, is a carbon group attached to C double bond O, OH. So this portion here is the carboxylic acid group. Halides were carbon groups attached to, I'm writing X here, but the X, remember, stands for the halogens, either chlorine, bromine, fluorine, or iodine. Of course, we would change their name slightly, but that's what that X refers to. And last, we have the ketones, which were carbon groups attached to a carbonyl, which is this, on both sides. Remember, the prime indicates not necessarily the same carbon group in both locations. You guys remember that stuff? Okay. So as a verbal review, I'm not going to write it in here. Alkanes, we recognize alkanes this way visually from the formula, the structural formula. The name of alkanes ends with a certain suffix, which tells the reader that it's an alkane. The suffix for alkane is ane. The suffix for alkenes, ene. The suffix for alkynes is yne. The suffix for alcohols is ol. The suffix for aldehydes is al. The suffix for carboxylic acid was oic acid. For halides, it was no suffix. Remember, for halides, we had a prefix where we changed the halogen from fluorine. We would change that to fluoro. So we would start with a prefix of fluoro, or chloro, or bromo, or iodo. And then for ketones, we had the suffix -one. Does anybody have any questions on any of that stuff from yesterday? Okay. We also had an issue of naming involving the number of carbons. You are responsible for up to 6 carbons. So if this column represents the number of carbons in the longest chain, the prefix we used for 1 was meth, for 2, eth, for 3, pro, for 4, bute, for 5, pent, and for 6, hex. Anybody have any problems with any of this stuff from yesterday? Okay, let's go ahead and name a few. So I'll just write a few things up here on the screen, and we'll name them together. Hopefully you have a reference there at the top of your notes. Okay. 6 carbon chain. What functional group would be present here? I'm sorry, you're getting ahead of the game. So what functional group is present? Alkanes. There is nothing else. And by the way, there's pretty much always going to be an alkane group. Think of that as a reference point. So we always start with that group. Anything else that's present becomes the dominant group that we use to name it with. For example, if I was to draw a double bond here, there's still alkane groups present, but the presence of this double bond is like think of it as a more important group in this case. We use that group that is not the alkane. We use it for naming purposes. Alkane is always present. So let me get rid of that double bond. Now, Justin already named it. It has 6 carbons long. It's an alkane, so the prefix is hex. The suffix is ane, hexane. Very simple, right? If we add functional groups, now we can no longer simply use number of carbons and the suffix. For example, a few minutes ago I talked about a double bond. So if I put a double bond in that location, we cannot call this hexene. Even though it is 6 carbons and the functional group present that is not alkane is the alkene, we have to indicate, in addition to how many carbons, what functional group, we have to indicate where that functional group is attached. The only time you need to do that is when the functional group could be in more than one spot. Okay, so for example, I'll temporarily draw it in red. Suppose I had put the double bond here instead of there. Those are different chemicals. So therefore, we have to have a number telling us where that functional group is, which helps us to differentiate between the two. So in this case, when we number, remember we start either on the left here from 1 to 6, or on the right from 1 back to 6. Remember, left to right means nothing on this whiteboard. It's a three-dimensional object that could rotate in space. So which direction do we choose? We choose the end closest to the functional group. So we start on this end, number that way. The functional group begins on carbon number 2, 2-hexene. Agreed? If the double bond had been in this location here where the cursor is, that would have been 3-hexene. Agreed? Yeah. Suppose the double bond was not where I had located it, but was in fact here. That would be 2. Remember, we wouldn't call this 4. We start numbering from the end closest to the functional group. It means we start numbering here now. That's 2. Questions on that? Wonderful. Let's continue. We'll stay on the theme of this 6-carbon compound, because this is the most complicated version. So let's start with some other functional groups. How about if there was an OH here? Okay. Now, what functional group is present by name? Say again? Look at your functional groups. That's an alcohol. This is the R group. Remember, it's the rest of the carbons. Here is the attached difference than an alkane. It's a hydroxyl group, which means this is an alcohol. So the suffix is going to be all. How many carbons? 6. So we're going to have hex. Now experience will tell you that there's going to be an AN in there, hexanol. Until you get good at this, I wouldn't be surprised if you said hexol, because that's the prefix and the suffix. The AN actually does serve a purpose. It does refer to the presence of these carbons that are singly bonded. But I'm not going to bother to worry too much about that. I'll keep saying it. Over time, you'll get the hang of it. However, this is not the final answer, because there are other 6-carbon alcohols, and that alcohol could be attached in a different location. For example, if I put the alcohol here instead of where it is written in black, those are different chemicals. Agreed? So we have to distinguish, again, with numbers. So in this case, the alcohol is attached to this carbon. Would you call that carbon number 1, 2, 3 or carbon number 1, 2, 3, 4?
3.
That's 3-hexanol. Sounds like you got the hang of it. Pretty simple stuff, right? Okay. I'll shorten up my carbon chain now to save some time. What functional group beyond alkanes is present here in this compound? An aldehyde. Good. And the suffix for aldehyde is al, not all. Al, A-L. How many carbons are in this aldehyde? 3. So this is going to be a propanal. Now, usually I would ask at this point, the functional group, where is it attached? But notice, the aldehyde is on the first carbon. As a matter of fact, it can only be at the end of a chain. An aldehyde has to be at the end or beginning, depending on your perspective, of the chain. And the reason for it is the carbon here has an octet of electrons around it. It can hold no more bonds. And another carbon cannot connect here, because hydrogen can't have that many. That's not possible. And this oxygen, I'm kind of leaving this off, this oxygen has 2 unshared pairs. It's also full. There is no more spots for carbons. So therefore, this is a termination group, or an initiation group if you prefer it, beginning or the end. No number is necessary. So with 3 carbons, it's propanal. What would it be called with 4? Butanal, not butanol, be careful. Butanal. What about with 5? Pentanal. What about 6? Hexanal. You got it. It's not that bad. Now suppose we change this to this functional group. What is that functional group called? Carboxylic acid. And therefore we know the suffix is oic acid. The prefix is determined by the number of carbons. There are 6 carbons, so this would be called hexanoic acid. You do not need to put a number. Why not? It can only be on the end. Same reasoning. There's no need to put 1 hexanol. It's understood that hexanol is that because it's redundant and unnecessary. Does that make sense to everybody? Does anybody have a question on naming some of these? Okay. There is, I'm going to go ahead and pause here. Yeah.